Okay, today in this video we're going to look at a max-min problem from Core 2 Math. These questions are mainly solved using differentiation, but there's a few different things we need to be able to do to set up the question first. So let's look at this example. In this one we got a solid right circular cylinder with radius r and height h. The total surface area of the cylinder is 800 centimeters squared. Part A, show that the volume of the cylinder is equal to 400r minus pi r cubed. So we kind of got to think, what do we already know about this question? And if we know that the surface area is 800 centimeters squared, we can write a little equation that will tell us the area. So for any cylinder, we know the area is equal to 2 pi r squared for the two circles at the top and bottom of the cylinder, plus 2 pi times the radius times the height for the curved surface of the cylinder. But in this case, we already know that the area is equal to 800. So we can write it like this. So because we know that the area is 800, and this is in terms of r and h, we could rewrite this equation in terms of either r or h. If we're trying to end up with a volume at the end for part A, and it doesn't have anything in terms of h, that means we really need to figure out what h is equal to so we can substitute it into our volume equation. So we're just going to rearrange to get h equals. So 800 is minus 2 pi r squared is equal to 2 pi r h. If we divide by 2 pi r h, we just get 800 minus 2 pi r squared all over 2 pi r is equal to h. So it probably doesn't look that simple yet, but we're kind of on the way to getting what we need. So we can cancel out 2 from everything here just to make it a little bit simpler. So we've got 400 minus pi r squared over pi r is equal to h. Okay, and if we remember what we're looking for in part A, we're looking for a volume. So in general, the volume of a cylinder is equal to pi r squared for the circle at the top times by the height. We have an expression for the height and we know that's there. So if we just substitute the height into here, we should be pretty close to getting what we're looking for. That will give us pi r squared multiplied by all of this. And now if we need to multiply by pi r squared, that's the pi here will cancel out with the pi at the bottom here. The r squared, one of the r's that we're multiplying by, will cancel out with this bottom r, which means we'll just end up multiplying everything on the inside by r. So we don't have to multiply by pi because we're dividing by pi. We don't need to multiply by r squared because we're dividing by r. So we're really just multiplying by r, which means the volume is equal to 400 times the radius minus pi r cubed, which, if we look back up at our original question, 400 times the radius minus pi r cubed. So we've managed to get the answer to pi for 4 marks. Okay. The next part says, use calculus to find the maximum value of v to the nearest centimetre cubed. So for this is where the sort of actual core mass comes in. And it says we need to find the value of r that gives us a maximum volume. So if we're thinking of finding a maximum value, that should always make you think in your head of stationary points. If we're looking for a stationary point, that means we're looking for a value where dv dr is equal to 0. So that means we need to find the differential and find the value of r that gives us 0 for the gradient function. So the differential would be dv dr. So with respect to r, if we're differentiating 400r, we'll just get left with 400. If we're differentiating pi r cubed, we multiply by the power, so we get 3 pi, and take 1 away from the power, so we get 3 pi r squared. And remember, we're looking for a point where this is equal to 0, because that implies that it's a stationary point. So 0 is equal to 400 minus 3 pi r squared. Okay, so now we need to rearrange to get r by itself. So we could add 3 pi r squared to both sides, and we'll get that is equal to 400. Divide by 3 pi, and we'll get r squared is equal to 400 over 3 pi. And finally, to get rid of the r squared, we square root. So r is equal to the square root of 400 divided by 3 pi. Okay. Obviously this is core 2, so we can put that into our calculator, which would give us an approximate value of r equals 6.5. Now this is a really common mistake. The question did not ask us to find the value of r. If we look back at the question, it said find the value of v, the maximum value of v. So we've got a value of r, and that should give us the maximum value of v, but we need to check that in part C. But for part B, we actually need to find what v is equal to. So we know that the radius is 6.5. We also know that the volume is equal to 400 lots of the radius minus pi r cubed. Okay, if we substitute our value of r into this equation, so if we substitute our value of r, we're going to use the more accurate version that r is equal to the square root of 400 over 3 pi. So we need to find this maximum value of v. So we're going to do v equals 400 times our value of r, which is the square root of 400 over 3 pi, minus pi lots of 400 over 3 pi cubed. If we put that into our calculator, it will give us the volume to the nearest centimetre is 1,737 centimetres cubed. So that will answer part B. We have found a volume to the nearest centimetre cubed that is the maximum volume of our cylinder. The final part says to justify the value of V that you have found and justify that it's a maximum. So as soon as you hear that it says to justify, we should be thinking of the second differential and remembering that d squared v over dr squared will tell us whether it's a maximum or minimum. So for our question, the first differential was 400 minus 3 pi r squared. So that was our first differential, dv dr. So that means the second differential, the 400 will drop out because it's a constant. Multiply by our power, so multiply by 2, we get minus 6 lots of pi, and then take 1 from the power r. So in this case, as before, we know that r is equal to root 400 over 3 pi, which means the value of this will be minus 6 pi lots of the square root of 400 over 3 pi. And again, using our calculators, that gives us a value for the second differential of minus 122.5, which that's a negative value, which therefore means we have a maximum value of v when r is equal to our value 6.5 or the square root of 400 over 3 pi. Okay, so hopefully that question makes sense. If you do have any further questions or comments, feel free to put them at the bottom of the video, but hopefully helpful. Thank you very much.